we're going to take your similar triangle proofs by angle, and we're going to extend it one more step today. One more step. So take a look at date. Make sure you're on day 4. Do not start marking your diagram yet. Just let me talk about what's in the proof statement. Take a look at what's in the proof statement of this first proof. That looks a little strange, doesn't it? We've never really seen that in a proof statement. If you go back to day 1 on Friday, remember, all I'm doing here, this is just another way of writing a ratio. FC with the colons to dB is just another way of writing it as a fraction instead. You could rewrite this as FC over dB. That's the same exact notation. All right, same exact thing we're saying. FC to dB is in the same ratio as AC to PB. That's what I'm asking you to prove there, is that those sides are in the same ratio. Well, wait a second. Those sides won't be in the same ratio until I know what about my triangles? Good. Anybody? What do I still have to know about my triangles for those sides to be in a ratio? They have, yes, good. They have to be similar. So I need to prove triangles similar before I get to this proof statement. So let's try to prove triangles similar first. Oh, wait a second. Son of a gun. Look at my diagram. I count at least 4 triangles, maybe 5 I can count now. 5 triangles in that diagram. Guys, which one are we going to prove similar? Which 2 are we going to prove similar? We just guess and cross our fingers and hope? Absolutely not. That's not how we roll in honors. Is there a way I could figure out what 2 triangles I need to prove similar? Because there's a lot there. Anybody have a thought on how I can find the triangles first that I need to prove similar?
They need to share angles.
This has nothing to do with angles yet.
They share those sides that you have to prove. They have those sides.
Sean, do you want to chime in now?
Yeah, on the proportion, the sides on the bottom are in the same triangle and the sides on the top are the same triangle.
Yep, I got a lot of people saying the same thing right now, just different ways. Look at the sides in your proportion. Find the 2 triangles that have those sides. All right, so go ahead and I'll ask somebody. First question of the day to somebody. All right, so go ahead right now. Look at the sides in the proportion and figure out what sides they belong to in the 2 triangles. And remember, they got to be full sides, full sides. So FC is a full side in this triangle. PB is a full side in this triangle. That's how we're going to find the 2 sides. So find the 2 triangles first, and let me know when you have those triangles. Let's start this off. 1, 6. Here we go. Kyla. Good morning, Kyla.
I'm sorry, can you repeat that?
I just said good morning. That's all I said.
Oh, good morning.
Good morning. How are you?
I'm good.
I'm doing well, too. Thanks for asking. Do you have the 2 triangles for me that contain those sides? Okay. I just wasn't asking how you were, Kyla. I actually wanted the 2 triangles.
Triangle DBP and triangle AFC.
Got it. So let me highlight this one first. AFC and along with BDP. Good job. All right, so those are the 2 triangles we're going to prove similar, so we can say their corresponding sides are proportional. All right, yesterday, you guys know, angle. That's our main method in proofs anyway, proving triangles similar. Angle. Now go to the givens if you haven't done so already. Do the givens provide any angles for me in those 2 triangles? I got AB congruent to AC. I throw this vocabulary term from Unit 5 at you called an altitude. Hopefully you remember what it does. And then I throw 2 perpendicular lines at you. So first thing I need, can you find a pair of angles anywhere? Or anything about the diagram. Let me just say that. Tell me whatever the heck you want. All right, other than I don't know how to do it. 10, here we go. Atticus, good morning. Here we go. Anything you want to tell me about the diagram?
Angle B is congruent to angle ACB.
Okay, I'm going to ask you, that is true, and I'm going to write that down. While I'm writing it down, why is that true?
Because it's an isosceles triangle.
There you go. So angle B congruent to angle ACB. And I know we haven't written it down in a few weeks, but in a triangle, congruent angles are across from congruent sides. All right, other things you want to tell me about the diagram. Here we go, 8 spot, here we go. Ryan, hello. Anything else you want to tell me about the diagram?
Angle PDB is a right angle.
That is true. Why is it a right angle?
Those perpendicular lines form right angles.
Nice job. PDB is a right angle. Perpendicular lines form a right angle. So Ryan just gave us a right angle, which means there has to be a right angle in triangle AFC too. Where is it and why? Where's the other right angle then? Oh boy. 2-0. Radhika, hello.
A and C is a right angle because altitudes form right angles.
There we go. We remember that definition of an altitude there. Good. AFC is a right angle. You guys can write definition of an altitude. I like to tell you what it's about. Altitudes form right angles. He really meant it, right? He really meant it at the beginning of the year when he said this vocabulary does not end when the unit ends. Altitudes form right angles. Good. They're not similar yet, though. What do I still need to tell you? They're not similar yet. 1-9. Here we go. Sean, what do I still need to tell you before they become similar? I'm missing an A.
Oh, that right angles are congruent.
Correct. You got to set those two right angles congruent to each other. All right angles congruent. And then, yep, there's the other A. So I have, little change up from yesterday, huh, kids? You got to write your own similar statement. Yesterday, you just copied down the proof statement. Got to write your own. Make sure it's in the correct order. Angles and sides match up when you write it. What do I want to do? I'll go PDB for me. Similar to AFC. You don't have to match mine. That's by angle. Also check before we move on. Do you have the similar sign between the two triangles and not the congruent sign? Have some self-respect. Don't be an embarrassment. Make sure the similar sign's there. All right, here we go with our extra step today. Triangles are similar. That means the corresponding sides are proportional. And you can write it as a fraction or as with the colons in between, whatever floats your boat. All right, now we're just putting it officially into a proof now. The triangles are similar. The corresponding sides are proportional. If you want to write that, fine. Corresponding sides are proportional, but we do have an abbreviation at the top of your page. It's a relative of CPCTC. Corresponding sides in similar triangles are proportional. CSSTP. If you're going to use it, make sure the correct letters are in the correct order. That's all I ask. Corresponding sides in similar triangles are proportional. Little relative of CPCTC.
I was gonna ask, is this basically this similar triangles version of CPCTC?
You are correct, because it's used in the same exact spot we would use CPCTC, but after proving triangles congruent now. All right, so yes. Yep. And then we got one more step tomorrow we could go. But for now, we're focusing on proving the sides are in the same proportion. Any questions about this before we do one more? Again, I don't have to hammer you with proofs here. There's only so many different types we could do. All right, one more here. I'll let you guys mark your diagram if you need it. This bad boy, ABCD, is a parallelogram. I shouldn't even have put part A and B. I don't know why I did that. I should have just put the part B and said, find the triangles yourself. But I don't know what's happening to me. Okay, can you help me prove CED similar to BEF? CED similar to BEF. Need two pairs of angles. Anybody have a pair of angles they want to give me right now in those two triangles? Oh, 1-8. Owen, hello, good morning. What do you got?
Angle C is congruent to angle A.
True. I'm not going to write, here's why I'm not going to write that down. Oh, because angle A is not in the triangles I'm trying to prove similar. So it would just be an extra step that I probably won't use. Okay, I'm trying to look for angles in those two triangles.
Okay. Angle CDE is congruent to angle EF because alternate interior angles are congruent.
Okay, let me mark them first here. So Owen's saying, hey, CDE and angle F. That is true because they're alternate interior, but that's not going to be my step 2. When are they going to be congruent? When what happens first? Anybody? When what happens first before they're congruent?
When extensions of parallel lines are parallel.
Okay, even before that, I have to tell you that DC is parallel to AB. For alternate interior angles to be congruent, I need parallel lines. Why are those two parallel? This bad boy's a parallelogram. Let's get with it, right? Parallelogram means you have opposite sides parallel. And then you guys just heard it. Saying that DC is parallel to AB isn't good enough because I'm doing angle F. I need to make AB longer. I need to extend it out to F. So I also need to say DC is also parallel to AF. And we used extensions to get that. So you have to tell me the lines are parallel before you get to the alternate interior angles congruent. Now I can say angle CDE is in fact congruent to angle F. I know it's been a while, not really, but you guys have used it enough. Parallel lines imply alternate interior angles congruent. All right, there you go. We got a pair of angles rocking. I need one more pair of something. And you can thank, oh, and he didn't take the easy way out on that one. 13, Sophia, go ahead. You can take the easy way out now.
Angle CED is congruent to angle BEF.
Yeah, because what are they, Sophia?
Vertical angles.
There you go. DEC and BEF. Now, if anybody wanted to, in step 4, put the other pair of alternate interior angles, angle C and angle EBF, that's fine too. All right, you don't have to mention vertical. And there's my other pair of angles, and we are ready to finish this bad boy off. Now tell me the truth.
How would another set of alternate interior angles help?
What do you mean? Angle?
You said something about being able to use another set of alternate interior
Yeah, there's
angles?
2 sets of alternate interior angles. The one we used in the proof, and then angle C and angle EBF are alternate interior.
Oh, okay.
Right? Okay, so what I'm just saying is you don't have to mention vertical angles if you're going to mention both pair of alternate interior. All right, make sure your similar statement is correct. Oh, actually, it doesn't really matter. I gave it to you. One job. CED similar to BEF, angle. And then, hey, I know I asked you to prove triangles similar, but you may just want to take a peek because, I get a little nuts every once in a while. Making sure that that proportion I set up for you to prove actually is in both of those triangles. So CE and DE, yep, all right, those are in that triangle. And BE and FE, yep, they're in triangle BEF. So just make a, you never know. It is honors. CSSTP. Anything from you guys before we finish this day off with a nice, hardcore, honors level algebra problem? I know you're excited for me to say that. Anything on this proof? All right, buckle up. Calculators fired up. Let's get after it here. Let's get after it. AB is parallel to CD. Got it. What's X in simplest radical form? All right, I'm going to challenge you first because I know a lot of you are just going to set up your proportion and get going. Why are you setting up your proportion? Because you're not allowed to do that until the triangles are similar. No proportions until the triangles are similar. So I'm going to challenge you guys right now. Prove to me why these triangles are similar by angle, angle. All right, I'm going to ask somebody, where are the angles here that are congruent? All right, because you can't set up that proportion until the triangles are similar. So prove to me they're similar first, and then we'll move on. So anybody see a pair of angles that they know are congruent in triangle FAB and triangle FCD? Name a pair of angles that must be congruent. 9 spot. Here we go. Audrey, do you see any angles that should be congruent?
CFD.
The reflexive angle. Good start. F is reflexive. It's in both. Good, good. There's A. Where's the other A in angle, angle? Here's a hint if you guys can't see it. Look at the parallel lines. They're forming another special type of angles. Look at the parallel lines. Where's my other pair of angles here? Top of the page. Vinny, do you see the other pair? Triangle FAB and triangle FCD. Where's my other pair of congruent angles?
I don't see it.
Okay, look at angle FAB and angle C. What did we call those when we started talking about parallel lines? Those are what type of angles?
Corresponding angles.
There you go. So everyone see those. And now you see why the triangles are similar by angle, angle. All right. So you proved to me the triangles are similar. Now show me that corresponding sides are proportional. CSSTP here. Quick question. Can I use side splitter? Anybody? Can I use side splitter here? Side splitter? Anybody? Nope. Don't make that mistake. It does not break the parallel sides up proportionally. If you're given the parallel sides, no side splitter. All right. So let me turn it to you guys. Woo, 20. Let's roll. Radhika, going back to you. Can you give me a side in triangle FAB that we know?
AB.
AB is 4. Nice and easy, Radhika. What's it match up with in triangle FCD?
X plus regular CD.
Yep. So just so you know where Radhika's getting this from, she's saying AB matches up with CD. I just want to show you where everything matches up. All right, give me another side in the small triangle so I can finish my proportion here. 10, here we go. Atticus, give me another side in the small triangle.
X minus 1.
Okay, X minus 1. Atticus just gave me FA, everybody. What does FA match up with in triangle FCD now? What's FA match up with? This is the toughest part. 5, here you go. Hayden, what does FA match up with? What side?
FC.
FC. So we got to do some combining of like terms here, Hayden. So X minus 1 plus that 2 will give me what?
X plus 2.
X plus
2.
You sure? You got X minus 1 and then you got 2.
Oh, X plus 1.
X plus 1. Good. All right, everyone, that's always a catch for kids. Also, please combine. Hey, please do not write this in the proportion. X minus 1 plus 2. Can you clean it up before putting in the proportion? Clean it up. All right, good job. So we got the proportion set. Let's roll now. Cross multiply. I get 4 times x plus 1, and then I get x plus 3 times x minus 1. I am around, I am available if you are struggling with this double distribute FOIL concept. So I'm going to let you guys go to a certain step. Do all your multiplication, set one side equal to 0, and then we'll talk. That's as far as I want you guys to go. Distribute, FOIL, double distribute, set one side equal to 0. Do a little work on your own here, and then we'll check with me. Just get one side equal to 0, and then please stop. We will move on from there. Keep your x squared positive when you're deciding what to move over. Keep your x squared positive. All right, you ready? Let me know what you got. What's equal to 0 here? When you get there, what's equal to 0? Quincy, here you go. What's equal to 0 here?
Oh, I'm still working on it. I haven't gotten it yet.
Okay, let me know. I got x squared ready, and then you tell me the rest.
Yeah. Well, I got the right side ready, but I still haven't.
I want you to move everything over for me, and then tell me what's
All right.
equal to 0.
Is it x squared minus 2x and then minus 7?
You got it. There we go, guys. X squared plus minus 2x minus 7 equal to 0. All right, you guys have options, right? Factor or quadratic formula. But here's the problem. You guys try to factor this. I don't think you're going to come up with any numbers that multiply to 7 but add to 2, are you? I don't think so. There are no numbers that multiply to 7 and add to -2. So I'm going to be forced to use quadratic formula here. Oh, wait a second. Wait, before we do that, I'm going to let you guys in on a secret. Before we even started this problem, I knew we would have to use quadratic formula. Look at the directions. Anybody know why I said that? Look at your directions. It said what? Leave your answer in.
Simplest radical form.
And the only thing you get a radical from is the quadratic formula. You've never gotten a radical out from factoring, I hope. So that tips you off at the beginning of the problem. Hey, don't even try to factor. You know it's going to have to use quadratic formula. And you'll see that in the directions from me. All right, leave it in simplest radical form. Got to be quadratic formula. All right, let's do it. Before I start with the quadratic formula, I need someone to give me my A, my B, and my C value here so I can plug it in correctly. A, B, and C, what do we have? 10. Atticus, third time's a charm. What's my A, B, and C here? Let's start with the A value.
1.
B?
-2.
And C?
-7.
Good job. If you guys are struggling how to find those, let me know. All right, time for the formula. I will give it, you know you're probably going to have to use it next week on the test. I will give it to you. But I can't help you use it, though. I can give it to you, but I can't help you use it. All right, x equals. Atticus said the B value was -2. If I do -2, this first number becomes 2. Plus or minus, I'm going to store values into my calculator to find the number underneath the radical. If you guys want to go ahead and plug it in and do it yourself, hey, go ahead. You might be playing with fire, but go ahead. All right, I'm always going to use my calculator. all over 2 times a, which was 1, so it'll just be 2. All right, grab that calc if you're going to do it with me. Here we go. I'm going to take 1, store. Remember, the store button is the button to the left, STO with the arrow pointing to the right. Store that in for the A value, which is above math on the left-hand side of your calculator. Alpha math. Enter. What do I got for B? -2. -2. Store that in for B. And once you guys know where the buttons are, you guys, I'm sure, can do this pretty quick. I'm sure you're doing it like you're texting on your phone. -7. Store that in for C. All right, everything's in there. Now let's just find out the value of B squared minus 4AC. I'm never going to get it wrong when I use my calculator. 32 underneath the radical. 32. All right, I can break down 32. It's at simplest radical form. I can break down 32. So I'm going to look for somebody. Biggest perfect square that goes in the 32. A third reminder here. If you need your perfect squares, go to your y equals screen, type in x squared. Type in x squared under y1. Go to your table, and there are your perfect squares if you ever need them. Biggest perfect square you found. 2, 1. Zach, hello. Biggest perfect square you found, Zach.
16.
Nice job. It wasn't 4, everyone. It was 16 times what, Zach?
Times 2.
Good job. So we end up with 4 radical 2 to plug back in. 4 radical 2. X equals 2 plus or minus 4 radical 2 over 2. We're getting there. It's in radical form, simplest radical form, but it's not simplified yet. We still got some work to do. Look to the left now. Look to the left of the plus or minus. You have a 2 divided by 2, which in my book is 1. So left side gives you 2 over 2, which is 1. Right side of the plus or minus is 4 over 2, which is 2. Radical 2. Everyone see where I got the 1 and the 2 radical 2 from? That worries me a little. Anything?
I did I stored everything in my calculator, and I still got the wrong answer. I didn't get 32.
That's garbage. You stored 1 in for A.
Yes.
-2 using the negative sign in for B.
Oh, wait. I don't understand what I got wrong.
One job, Maeve. One job. Everyone else, all right? I'm not circling. I hope you guys haven't circled that in and started the homework yet, because there's a problem. And this is where we have a moment where we awkwardly stare at each other in Google Meet until somebody tells me what the problem is. We got a problem.
We don't know the values of x.
Okay.
Can x not be negative because it's a side?
Grab
So
your
it's only plus?
Grab your calculator, everyone, right now. Grab your calculators. Remember, when you write it with the plus or minus, you actually have 2 answers, right? You have x equals 1 plus 2 radical 2, and you also have another answer, 1 minus 2 radical 2. Everyone, grab your calculator and type in 1 minus 2 radical 2. One minus 2, and everyone see that negative 1.828? What would happen if you took that answer in your calculator, went back, and plugged it in for side FA? If you plug that number in for FA, what type of side are you going to get? A negative side. No go. No go. So even with the quadratic formula, you still have to watch out about getting a negative side. Go on. All right, I cannot accept that because it gave me a negative side length. So even when you guys use quadratic formula tonight on your homework, still watch out for any answers that give you a negative side. All right, same thing we would do with factoring, right? We do the same thing with factoring. All right, that's all I have for you. There's only 4 problems tonight, 2 hardcore algebra ones and 2 proofs. So no reason why we can't get after it tonight. All right, we still have 3 minutes left, but I'm not going to ask you to start the homework with 3 minutes left. So you guys are good for me. You guys have any questions before we leave each other?
Just a quick one. It does say, looking at the homework, one of the questions says, find x to the nearest 10th. Is that another way of knowing that we need to do it in radical form, or that we need to use quadratic formula?
Correct. And now, if tonight on homework, Sophia, when you get to that point, see how where we got on this last problem we did? So now all I'm going to do, Sophia, is go to my calculator, do 1 plus 2 radical 2. I'll get a decimal, and I'll round it to the nearest 10th tonight, and that'll be my answer. Okay, that's all. And then if you need to reject one of them, you reject one of them. But yep, no problem there tonight when I ask for nearest 10th. Good observation. You are going to have to use the quadratic formula on that first one. Yep. All right, guys. Have a great day. It was a good class today. Good job. Have a good one.
I have a quick question.
Yeah, go ahead.
Why would FC, when you're making the proportion, be x plus 1 instead of 2x minus 2?
Okay, because if I want to get the length of FC, Radhika, I'm going to take FA and I'm going to add it to AC. You agree?
Right.
Okay, so FA is x minus 1, AC is 2.
Oh, you add them. Okay.
Yeah, I'm not going to multiply them or anything. I got to add them together to get to the full 2 parts. Add them together, you get the full part.
Okay, thank you.
Good. You're welcome.